Today I'm going to explain how to use Vernier rotary motion sensor to verify the conservation of angular momentum. First of all, I'm going to explain how angular momentum works. So angular momentum basically equals to the I times omega. So I is moment inertia, which depends on mass, how mass is distributed, and also the radius. Omega is angular velocity, so that's the total angular momentum before. This one should equals to total angular momentum after. So the whole conservation of angular momentum depends on there's no net torque acting on the system. So by give a little angular velocity to this disk, and also I can collect data. So collect. So you can see now I have a constant angular velocity. Now I'm going to give this disk another angular velocity. So it's rotating really quickly. Now here I have a second disk. So if I drop the disk to this disk here, so I'm expecting the angular momentum will be conserved. So that because moment inertia is doubled, so the angular velocity will be halved. So let's try this. So let me. Now I'm going to gently drop the second disk on the first disk. Okay, 3. So 3, 2, 1. Now let's look at data. That's how beautiful the data is. Now I'm expecting the first angular velocity is 11.82. Now let's look at the second angular velocity. That's 5.81. So you can see that roughly now this angular velocity should be doubled the angular velocity after I drop the disk on the first disk. So this is how conservation of angular momentum works.